Good morning, children. Today we are going to see the second module, types of chemical changes. I think you all have followed the first module content, how to balance the chemical equations. So we have learned how to balance the chemical equations. And we have practiced in-text questions, exercise questions, pre-board board questions, and also some other examples. I hope so that you are now confident in the first topic. So my suggestion is, when you are reading whatever the topic, if you are not confident, concentrate on the topic and get it full. So that's why every day I am trying to give one topic to you. So today's topic is types of chemical changes. So there are 4 types we are going to see in this topic. First, chemical combination, chemical decomposition, chemical displacement, chemical double displacement. At the same time, we are going to learn some chemical reactions such as exothermic reaction, endothermic reaction, and precipitate reaction, photochemical reaction. Along with this content we are going to see. So, are you ready now? So first, combination chemical reaction. Now take a quick line in a conical flask and add water to it. So this quick line you need to take in conical flask and add water to it, and you touch it. You will feel warm. Why? Yes, it means some energy is released. So whenever energy is released while chemical reaction, such chemical reactions we will call it as exothermic chemical reaction. Exo, out, releases out. Thermal, heat. Exotherm means releases heat out. Now in this reaction, what did we see? We saw that while adding water to the quicklime, some heat is released, and when you touch the conical flask, you will feel it warm. Okay, now what compound or products are formed? You will see that we got only one product. That product is called calcium hydroxide. That calcium hydroxide is also called as slackenide. That calcium hydroxide is also called as slackenide. You getting? Slackenide. Now see, how many reactants are there here? Calcium oxide is one reactant. Water is one reactant. So 2 reactants have combined. And how many products we got? 1 product. So when 2 or more reactants combine and give single product, such reactions we will call it as chemical combination reactions. Such reactions we will call it as chemical combination reactions. So we can see so many examples now. In your day-to-day life, we see that particular thing. Burning of wood. Burning. If you go to kitchen, your mother is cooking some food. No, if you see that something is burning there. But I am not discussing about that burning. If you have taken the wood, most of the thing in the wood is carbon. When you burn the carbon, It reacts with oxygen and forms carbon dioxide and releases large amount of heat. Now you see, Nana, how many reactants are there? 1, 2. 2 reactants have combined and gave one product. So this burning of carbon is also an example of chemical combination. As heat is released during chemical reaction, this chemical reaction is also example of exothermic reaction. Now we are going to see another thing, hydrogen. Do you know how that name has come? Hydrogen is combination of 2 words. Hydro means water, gen means water generator. While keeping the name hydrogen, we observed that gas, when it is burned, it is giving water vapor. So when hydrogen is burned, it gives what? Water vapor. Because of that only the name hydrogen has come for the hydrogen. So this reaction also, you can see that H2 plus O2 gives rise to H2O and releases some heat. Is it balanced? No. I need to put 2 here, 2 here. So now it is balanced. So it is compulsory that whenever we write an equation, we need to check whether that reaction is balanced or not. Okay. So now did you understand the combination? So what does the combination reaction say, sir? When 2 or more reactants combine and forms a single product. And also we have seen most of the combination reactions are exothermic. What is exothermic reaction? Whenever heat released during chemical reaction is called exothermic chemical reaction. So now we have seen 3 examples of combination. One is calcium oxide plus water, calcium hydroxide, carbon plus oxygen gives rise to carbon dioxide, hydrogen plus oxygen gives water vapor. Where do we use this particular thing, calcium oxide, in the manufacture of cement? In manufacture of cement, calcium oxide will be used. Not only there, while whitewashing also, we use this particular thing. What happens? You have taken the quicklime and you have added water, you apply it to the walls. So, slowly it reacts with the carbon dioxide in the atmosphere. This one, calcium hydroxide, reacts with carbon dioxide and forms calcium carbonate and water vapor. So, this calcium carbonate is only shiny surface that we see on the walls, whitewash. So, now you say which chemical we used in the whitewash? Calcium oxide only. We apply water and we apply onto we mix with the water, we apply to the wall. And here one more thing I want to discuss is respiration, breathing. We are doing during respiration, that oxygen we are taking in, it reacts with the food content that we have taken. Food contains carbohydrates and biological process it converts into glucose. That glucose reacts with oxygen that gives us energy. Because of we respire, we are getting the energy. As energy is released in this particular process, respiration is also called as exothermic reaction. Why? While taking oxygen, oxygen is combining with food. How? That carbohydrates is converting into glucose. That glucose is combining with oxygen and releasing the heat energy. And decomposition of the vegetable waste and converting into compost, that decomposition of the vegetable compost is also an exothermic reaction. So Nana, today what we have learned in this particular topic, we have seen there are 4 types of chemical changes are there. In that first type, what we have seen? Combination. What is a combination reaction? When 2 or more combine and gives a single product, that reaction is called combination. And we also have seen some examples. And exothermic reaction also we have seen. What is an exothermic reaction? When heat is released during a chemical change, that reaction is called exothermic chemical reaction. Next, we are going to see the second topic is decomposition, chemical decomposition reaction. It is exactly opposite to the combination. In combination, what happened? Two or more reactants combined formed a single product. But here, single reactant will split into two or more products. Single reactant will split into two or more products. For that, it requires some energy. Whenever any chemical reaction requires energy, we call the chemical reaction as endothermic reaction. We call the chemical reaction as endothermic reaction. If these reactions are endothermic reactions. Now let us take one example, calcium carbonate. Calcium carbonate, on heating, the calcium carbonate releases large amount of heat energy. Calcium carbonate, on heating, it decomposes into quicklime and carbon dioxide. So this happens only when we supply the heat to it. You see, only one reactant has split into two products. So this happens only when we supply the heat. On heating, it is better to write a heating, or else delta symbol is also represents the heat. So this type of reactions we will call it as decomposition reactions. Now let us see one experiment. I have taken green colored iron sulfate crystals. Iron sulfate crystals in a test tube. This one I have taken in a test tube. And I am burning, and from here I am observing. So in this, what is the green color iron sulfate crystal. So on heating, do you know what happens? This green color will be fades out. Why? This water molecules will be gone and we will have iron sulfate. So when water molecules are being left out, then we will have colorless or white powder iron sulfate. Now I continue to heat, then I am going to get Fe2O3 ferric oxide, and I am going to get sulfur dioxide and sulfur dioxide. These gases are somewhat poisonous gases. These are the gases will be released. As these gases are not good to health. Now what is the best way to hold the test tube? Is it good to hold the test tube like this and to see? So we have to keep the test tube away from us. This is the precautions we have to take. Always keep the test tube away from us. Otherwise, we will get the fumes into our nose and it causes us sick. So those gases are not good for health. So we need to take the precautions. Always keep the test tube away from us. Always away from us. If you see this one, a single reactant, iron sulfate, has given 3 products. If one reactant gives 2 or more products, such reactions we will call it as decomposition reactions. Okay. Now another reaction we are going to see, lead nitrate. Lead nitrate on heating, it gives lead oxide, nitrogen dioxide and oxygen gas. Is it balanced? No, it is not balanced. Now we need to balance it. So balance it. I will check here lead and lead oxygen are balanced. Here 6 oxygens are there. And I am going to see here nitrogen 2 are there. If I put 2 here, then how it would be 4, 5, 6, 7 are coming. And here 6 oxygens are there. Here 2 nitrogens are there. Nitrogens and lead oxygen is balanced, 7. So if I make 1 by 2 here, then you see 4 plus 1 plus 1, 6. But what is the factor we learned in balancing the chemical reaction? Can we keep the fractions as quotients? No. So I don't want R here. So the entire equation I am multiplying with 2. So that's why 2, 2 and this will become 4 and this will become 1. Now this is the balanced chemical reaction. Here also on heating, what we have seen, the lead nitrate single reactant has been divided into 2 or more products. When a single reactant divided into 2 or more products, such reactions we will call it as chemical decomposition reactions, which is exactly opposite to the combination. In combination we have seen 2 or more reactants combine and form a single product. Here single reactant is giving 2 or more products, but here it requires some energy to do that. Which energy it has taken? Heat energy in these 2 examples. That's why these reactions are called thermal decomposition reactions. Thermal. Why? Because they absorb the heat and then they have decomposed. That's why we will call it as thermal decomposition reaction. Now we are going to see another example in decomposition reaction. Their heat energy quotient so with the help of electric current, so the water undergone reaction. Then you can see that in one of the test tube, some gas will be there, in another test tube, double of the gas will be there. What happened now? So water on electrolysis with the help of electrical energy, it decomposes into hydrogen gas and oxygen gas. You can see that hydrogen gas is 2 parts and oxygen gas is 1 part. That's why we have 2 parts of hydrogen and 1 part of oxygen. So with what energy now these hydrogen, a single reactant decomposed into 2 or more products means, what energy have we had taken? Electrical energy. Okay, so this type of reactions we call it as electrolysis. Now we are going to see another one, a white powder. I have taken silver chloride. A white powder I have taken. This is silver chloride. Now I kept it in the presence of sunlight. Now you will see that one turned into the grey color. It's not balanced. I am balancing it. The white silver chloride, it turned into the grey color. But with what energy it has turned? With the help of sunlight. Not only this, silver bromide also the similar way. It will convert into silver and bromine. These reactions are used in black and white photography. In olden days, nowadays we are having everything in cell phone color printers we are getting, but long back, your grandparents' days and my father's days, they used to use the black and white photographs. Even some of the photographs are there, I know they are black and white photographs. So while printing the black and white photography, they have used this chemical reaction. So this chemical reactions are used in black and white photography. But here the sunlight is required, sunlight. And with the sunlight, what happened? It decomposed into two products. That's why this is also the best example for decomposition reaction. What is decomposition reaction? Decomposition reaction states that if a single reactant decomposes into two or more products, such reactions we will call it as decomposition reactions. Okay. Now we are going to see one simple example. Nana, you just take barium hydroxide in test tube, 2 grams of barium hydroxide and 1 gram of ammonium chloride, and see what happens. For this reaction, it happens. It requires energy, but it takes the energy from the content itself. And the temperature will come down to 20 degrees. That's why when you touch the test tube, you will feel it cool. So what do we observe while touching the test tube? We observe it is cool. It has absorbed the energy. Okay. So whenever any reactants absorb the energy to perform the chemical reactions to give the product, such reactions, what do we call it as? Endothermic reactions. Here all those examples we have seen, they have absorbed the energy in the form of sunlight, in the form of electric current, in the form of heat. So whenever any reactant absorbs the energy to give the products, such reactions we will call it as endothermic chemical reactions. All these are examples of endothermic chemical reactions. Now we are going to see the third type of chemical reaction, displacement reaction. Displacement reaction. Let me see one simple experiment. Take copper sulfate solution. Copper sulfate solution color is blue. Now keep an eye and wait for some time. You will see that this copper sulfate color will be faded out, and on the iron nail some copper will be coated. What happened? This copper sulfate, when reacts with iron, displaces copper and forms ferrous sulfate and gives the copper. So the copper is displaced, and we know the color of the copper sulfate, ferrous sulfate is green. The blue color copper sulfate is now converted into the green color. So iron displaced copper. Now let us see some other example. If I have done with the zinc also, now I get zinc sulfate and copper. Zinc also displaced copper. Now instead of zinc I have taken the lead. I will get lead sulfate. Lead also displaced copper. But in reverse, if I put the copper in the iron sulfate, you will find that there is no reaction occurs. Why? What are the examples we have seen now? Iron, zinc, lead, these are all displaced copper. So the copper is less reactive. Copper is less reactive than all these things. These are all more reactive than copper. So the more reactive metals will displace less reactive metal. This type of chemical reactions we will call it as chemical displacement reactions. Okay? So many examples are there, but once again, what is a displacement reaction? More displaced element will displace the less reactive element. This type of reactions will be displacement. And now we are going to see the last one of these types of reaction, double displacement reaction. Double displacement. So in double displacement reaction, what happens now? One compound and another compound with respect to ions will be there, mostly ionic compounds, and these will be exchanged. The exchangement of ions occurs during the double displacement reactions. Suppose if you take the sodium sulfate, Na2SO4, when it reacts with barium chloride, you will see that this and this will be exchanged. So we will get barium sulfate and sodium chloride, and this barium sulfate is precipitate, undissolved solution which settles down. We will call it as precipitate. That's why this solution is also called as precipitate. This reaction is also called as precipitate reaction. Undissolved solid or chemical in that solution will settles down. That undissolved solution or undissolved substance which is settled down, we will call it as precipitate. Here in this reaction, which precipitate has formed? Barium sulfate precipitate has formed. That's why here you can see that the barium and sulfate exchanged their positions, barium and sodium. So mutual displacement of ions occurs in double displacement reaction, and mostly in precipitate form we call that as a precipitate reaction. So here the white precipitate, which is barium sulfate, is formed. That's why this reaction is also called as precipitate reaction. Now let us see another example, lead nitrate. Lead nitrate, when it is reacted with potassium iodide. Lead nitrate, when it is reacted with potassium iodide, I got lead iodide and potassium nitrate. So now I am writing simple equations, but every time I forgot to balance some of the equations, but every time we need to balance the chemical reactions. Here I put 2, here I put 2, now everything is balanced. So this one is precipitate. Lead iodide is precipitate, and you can see that what and what exchange here? The lead and potassium, the mutual exchangement of radicals is called double displacement reaction. This reactions sometimes also called as precipitate reactions when one of the product is precipitate. What is precipitate? Undissolved solution or undissolved substance which settle down at the bottom of the beaker or bottom of the test tube. That is called precipitate. Here which one is precipitate? Lead iodide is precipitate. Okay, Nana? So what are the 4 different types of chemical reactions we have seen? Chemical combination, chemical decomposition, chemical displacement, chemical double displacement reactions we have seen. So in a simple method, in terms of A and B, if 2 or more combine and forms a single product, we will call it as chemical combination. If one reactant splits into 2 or more products, we will call it as chemical decomposition. You can see these both are opposite to each other. Now, chemical displacement, when high reactive metal displaces the low reactive metal. high reactive metal displaces the raw reactive metal. Such reactions we will call it as chemical displacement. The mutual exchange of ions occurs in double displacement reactions. And also we have seen exothermic and endothermic. What are exothermic reactions? When heat is evolved in the chemical reaction, such reactions we will call it as exothermic reactions. When heat is observed, then such reactions we will call it as endothermic reactions. Not only that, we have seen the precipitate reaction. When one of the product is precipitate, undissolved, such reactions we will call it as precipitate reactions. And also we have seen electrolysis, photochemical reaction. Also, what is electric? With the help of electric current, mostly that will be split into the products. And photochemical reactions, this occurs in the form of sunlight. Okay, these are the reactions we have seen. I hope so that you understood. So we are going in a different manner. What is that means? One topic will sit and we'll understand and we'll try to understand. When we get it, then try to answer stepwise. First, in-text questions, and second, exercise questions. Very beautiful questions they have framed. That doesn't mean that these questions only will come in the examination. So sit and write in-text questions related to this topic and exercise questions. And after that, practice the board questions. Then you will understand what type of questions we are getting in the exam. And then question bank. So all these questions I have put in this link. You can see the down link in this one YouTube. If you press it, you can find the content what I have explained, and also in-text questions answers, exercise answers, board questions, and also question bank. Please, I request all of you go through these questions step by step and try to answer those questions by self. Definitely 100% I can give assurance that let whatever may be the question gives from this topic, you will be in a position to write. Now only one question, board question I want to discuss with you. So one board question has given like this. Now you can easily answer. So it's only for idea I am giving. The question is given like this. 2 grams of silver chloride is taken in china dish, and the china dish is placed in sunlight for some time. What will be your observation in this case? Try to recollect the picture. Got it? We have taken the white powder, silver chloride. When we put in sunlight, what happened? The grey color silver and chlorine gas is released. Got it? What do we call these reactions as? Photochemical reactions. Where do we use this one? Photography. And they're asking, write the chemical reactions involved in the form of balanced chemical equation. Whatever the questions given in this, whatever the question, always they ask to balance the chemical reaction. So it is make a habit to balance the chemical reaction every time. So in this question, what is the equation? And we will balance it. Silver chloride, AgCl. In the presence of sunlight, what happened? That is what we need to write. It decomposed into silver and chlorine gas. And this is powder. This is white powder. And this is the grey color. Now you can see. Now what happened? How many products are there? So how many reactants are there? 1. And how many products are there? 2. And they asked us to identify the type of chemical equation. This is very important. So whatever the chemical equation we have written, we should identify out of this 4 and exothermic or endothermic, whatever it may be. So what type of chemical equations, chemical reaction this one? It is chemical decomposition reaction. chemical decomposition reaction. So like this, some questions will be there. I am going to read the question, but you try to answer. Identify the type of chemical reactions takes place in each of the following cases and write the balanced chemical equations for the reaction. Now, did you understand what type of the questions we are getting? They are asking us to identify what type of chemical reaction. And second, they are asking us to balance the chemical equations. So, I already said writing the chemical formula is very, very, very important. So, if you know how to write the chemical formula, it is well and good. If you don't know, please write and by hand the formulas for time being and slowly learn how to write the chemical formulas so that you cannot commit any mistake. Okay, Nana? All the students, please, it's my request. Please go through the link below given there and see the content, read the content, watch this video full. And second, answer the in-text questions separately. Answer the exercise questions separately. By the time you will get full idea about the content, and try to answer the board questions, that is also given separately. And at last, question banks of questions are there. Please answer by yourself and check whether you have understood or not. Hope so. Definitely you will understand it, and we are going to see the next topic. So thank you, my children. Thank you very much. Stay safe, stay home.